Ready?
Yes.
Astronomy Cast, episode 578. Life on Venus? Question mark, exclamation mark, question mark. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Frasier Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. It has been the weirdest of weeks. I don't know about you, but every time we get one of these NASA media advisory or Royal Astronomical Society media advisory that is completely vague,
Mm-hmm.
someone asks, so it's not aliens, is it? And this time, when someone asked that, I found myself just sitting there going, shit.
Yeah.
It's been a weird week.
It's funny. So I don't know if people know about this. So the policy for Universe Today, and if any of my writers are listening, just a reminder, is that we don't look at embargoed stories. So
Right.
if you send Universe Today an embargoed story, we will delete it. We won't break your embargo, but we won't look at your embargoed story. We are not interested until after the embargo has been lifted. And the news is publicly available to everybody. And the reason why is I find that it allows people to decide who's a journalist and who isn't a journalist. It's sort of a way to control the knows and the know-nots. And for the longest time, a lot of really respectable, who I thought science journalists, were being held out of the embargoed news information. It's not so bad these days. And then the other thing is to sort of artificially inflate
Yeah.
the newsworthiness of a piece of news. And so you and a couple of the writers on my team were like, we got a really important embargoed news story that's come
Well,
across my desk.
and
Can we
I
work
wasn't
on
sent
this?
I wasn't
Yeah.
sent the embargoed information either.
Yeah.
But one journalism outlet that I'm not going to slander, I accidentally pressed the publish instead of the schedule button in
Yes.
WordPress.
Yeah, we
And
saw
so
that.
the article was out there. And of
Yeah.
course, this led to people going through and putting the pieces together.
Yeah.
So,
Apparently, you could even figure it out by looking at Wikipedia and seeing which articles in the astronomy and science section have been modified recently.
oh, gee, that I
Yeah,
hadn't noticed.
yeah, pretty
That's
clever
awesome.
to figure that out. But yeah, so I was just as unaware as everybody come Monday morning when the announcement was made, and it was totally worth it. What a great announcement to hear! It was maybe, possibly aliens finally, which we'll get into during the show.
Yes. Yes, we will.
All right, so have you heard the news? Of course you have. Evidence of phosphine on Venus, which could be a biosignature of life on our evil twin planet. There have been a lot of surprising stories about Venus, so let's get you all caught up. All right, Pamela, what's the news this week?
Okay, so this week's news, and we're going to have so many articles that we need to explain to give context to this news. This week's news is the biosignature molecule phosphine, which is one phosphorus atom and three hydrogen atoms, has been found in the atmosphere of Venus in amounts that can only be explained in ways that we know. The universe tends to be creative, but using physics and chemistry and biology that we know, the only way to get this much phosphine into an atmosphere is to stick microbes in that atmosphere.
There was a great article, I think it was the BBC did this. They said you can have pollution from industry or penguin poops.
Yeah, pick one.
Yeah, pick one. And so we know there are definitely not factories or penguins on the surface of Venus. Therefore, super weird to see this chemical in the atmosphere of Venus.
And this particular atmospheric gas is produced by a variety of anaerobic bacteria. This is single-celled life forms that don't need any oxygen, and there's not exactly a lot of free oxygen at Venus either. So what we're seeing is consistent with a kind of life that could exist there. And intriguingly, just in the past couple of months, a number of popular level articles and one professional article discussing how you could have a cycle of life in the atmosphere of Mars have been published.
Did you want to say that again about and use the word Venus this time?
What did I say?
Mars?
Oh, shoot. Thank you. And
Sorry.
remarkably enough, in the past few months, a number of popular level articles, including one professional article, have been published detailing how you can have the cycle of life in the Venusian atmosphere.
Yeah, it's pretty funny. There was a bunch of these papers on phosphine, on how life in the Venusian atmosphere could be generating phosphine like a month ago.
Yeah, yeah. And I had the opportunity to
Sorry,
ask Sarah Sieg.
apologies, I breathed a tomato like 10 minutes before. And my wife informs me that breathing tomatoes is
Recommended?
not how this works. Speaking of phosphine.
Okay.
Okay, all right. So let me just continue my statement here.
Okay.
So I actually had I had this paper by Sarah Seeger and team about how bacterial life could survive in the cloud tops of Venus and what the mechanism might be. We can get into this later on in the episode. I was like, oh, that's such a cool idea. I'm totally going to do a video about that. And so I put it on my list of videos. Little did I realize Sarah Seeger, playing three-dimensional chess here, had this all queued up and ready to go for the moment we got the announcement of phosphine on Venus. Everyone was like, where could it be coming from? And she can just go, wrote the paper. Very
And
smart.
and I asked her about that during an interview I did on the Daily Space, and she said that they hadn't initially planned to write that paper, but they'd been working with a journalism student who was doing such a good job that they decided to just move ahead with everything. So it is the fluke of having the right intern in the right place to motivate things forward that led to that earlier paper coming out.
Okay, so we've got the discovery of this incredibly weird element, phosphine, or molecule, sorry, in the atmosphere of Venus. We don't know of a natural process. So this is to the how do we know what we know part. How did they discover this molecule in the atmosphere of Venus?
I You pointed a couple of telescopes. So literally what happened here is people have been suggesting since, well, looking for biosignatures was a thing, that along with methane, phosphine was a particularly good biosignature. And unlike methane, which is super easy to make geochemically, um, phosphine doesn't seem to have the same geochemical way of being produced, at least not at Venus. So Jane Graves was looking in the Venusian atmosphere, following up on a number of other research threads. So just in the past year, we've had coming out of the European Planetary Sciences Conference last September, the idea that up until as recently as 750 million years ago, Venus may have had water, oceans, and a habitable environment before something catastrophic took place. We've had papers showing that if you use modern numerical models to analyze the Magellan data, looking at the surface features on Venus, it looks like there's still active volcanism
Right.
there. And then when you couple all of this with the known problem that there are these UV absorbing splotches in Venus's atmosphere that have no known explanation, except there's bacteria on Earth that have the same characteristics.
Right.
It sort of starts to become we really need to be looking for life here kind of situation. And what I have to admit, I didn't know until I was prepping to talk about this week, was the idea that Venus might have life in its atmosphere goes all the way back to the late 60s and hinges on those dark UV absorbers to a certain degree.
Right. So, I mean, I think one of the things that I really loved about this announcement was how careful and how skeptical the researchers themselves were, which was that they did really, really meticulous observations to determine the presence of the phosphine in the atmosphere of Venus, and then spent an enormous amount of time looking at every possible natural source that could be generating it, from volcanoes to lightning, to meteorite strikes in the atmosphere, to and even to the point where they said, okay, like, yeah, volcanoes could produce phosphine, but you would need 200 times as much volcanism on Venus as we have here on Earth. And although there might be evidence of recent volcanism on Venus, not 200 times as much as Earth.
Right, right. And so this is where they had a really cool interdisciplinary group working on this. So you had Clara Sosa Silber, who's the phosphine expert, who was looking at what are all the chemical attributes. You had Sarah Seeger, who is very much a theoretician looking at how do you understand things in the context of the atmosphere. They brought in people to look at geochemical processes, to look at photochemical processes. And across all of these different things, they also had to consider, okay, so we had a low signal to noise observation with the James Maxwell Clark telescope down in Hawaii. So let's apply for telescope time to get a better set of observations from the Atacama Large Millimeter Array. And they got those observations. They went through the trouble of trying to figure out, are there overlapping molecular lines that we need to worry about at this wavelength? They did their homework to make sure this wasn't wasn't a different molecule stepping all over their phosphine observation. They checked every box. And
yeah, and so they absolutely found phosphine.
Yes.
And they very rigorously ruled out every possible natural source of phosphine
that we know of.
That we know of. Exactly.
And,
yeah.
And that's the problem, is as new paper after new paper keeps finding, the universe likes to be far more creative than our theorists. So there always has to be that nagging concern of, well, what if there's physics that I hadn't thought of going on here?
Yeah. And right now, it's probably almost certain that they will discover physics that they didn't understand before, that there will be some geologic process, some weird combination of sunlight hitting phosphorus-rich acids that combine in different ways. Like we do know that phosphine, because it has those hydrogen atoms, combines very rapidly with oxygen. It oxidizes as quickly as it can. And so you can see phosphine in Saturn and Jupiter because they're oxygen poor environments.
And hydrogen rich. They have free hydrogen available to do the bonding.
Right. While Earth and Venus are oxygen rich. We've got plenty of carbon. In Venus, you've got all that carbon dioxide, dioxide.
And with Venus, so the thing is that it doesn't have that free hydrogen that we see in the gas giants. And so in this reducing environment, it's really hard to figure out, where did those hydrogens come from? And so this is where, like, the person with the PhD really wants to say, I'm sure we're going to find physics that we just don't know about right now.
Yeah, I just said that too.
But here's the thing, and this is one of the things that I'm really struggling with on this discovery, is NASA has invested a great deal of funding since the mid-90s into understanding what molecules are biomarkers. Mm-hmm. What molecules, when we see them in extrasolar planets, mean this planet probably has life. And we found one of those molecules in a world that, I have to wonder, if it was an exoplanet, would we be sitting here going, no? Or would we be saying a biomarker was found?
Yes.
And because it's Venus, which let's face it, most of us have been like, that's the one place not to go looking for life. Um, does this force us to be over skeptical?
Yeah.
It's this really weird internal conflict of, wait, but we identified biosignatures for a reason and we found one, but now we're saying it's probably not life.
Yeah. What's wonderful about this is that we do have an opportunity now to double check. So
Yes.
if we didn't see phosphine in the atmosphere of Venus, then it would, I think it would sit on that, it would be the gold standard of biosignatures that have been worked out so far, as you talked about. You know, up until this point, people thought, oh, it's oxygen, it's ozone, it's water vapor, it's
Nothing.
methane. Yeah, it's methane. It's all these things, and now it turns out we've found natural processes that can supply each one of these. But this one molecule, phosphine, has held out, defying any natural cause that isn't life or industry in a oxygen rich world. And suddenly it's been discovered on a world that's very close that we can double check, because now you can send a spacecraft, you can send a balloon, you can go and examine it more closely and try to figure out what the source of this is. But if James Webb detected phosphine around Gliese 582 or whatever,
Yeah.
there's no double checking. You can't go and send a spacecraft to just give the atmosphere a sniff. And
So
so this is a wonderful opportunity.
so here's the story we have right now from various observations. We have from the Magellan data of the surface, an understanding from coroni. These are the um, geologic signatures in the shape of the ground saying this is where there's a hot plume of magma beneath the surface. We have evidence from Magellan's radar data of the surface that there are order of 30 volcanoes that appear to have been geologically recently active. We have brand new climate models thanks to advances in computing, and the advances in the computing also got us the volcano results. Thanks to advances in computing, we have new atmospheric models that consider, well, okay, so we're now understanding that during the Great Heavy Bombardment, watery things crashed into the inner worlds. Mars had oceans, Earth still has oceans, Venus should have had oceans. So let's run the climate models, assuming the water is there. And it appears that from these models, as recently as 750 million years ago, you had Earth-ish, Earth-hot environment capable of sustaining life and having oceans. 750 million years ago here on Earth, we had the beginning of colonies of single-celled organisms. So things like sponges that are made of single-celled organisms that act as a group, we had those. And so you can imagine on the same time scale, life having the ability to come into existence on Venus, or panspermia to have done whatever
Right.
it felt like doing between these three planets.
Yeah, and I guess that's the other question is I mean, if we do find life on Venus or Mars or Europa or Enceladus, um, are we related?
Yeah.
And and when?
And so we have those questions. And then we have today the active and changing pattern of UV dark absorbers in the atmosphere of Venus that have characteristics that are mirrored by actual bacteria that can temporarily rise up into the Earth's atmosphere for hours or days, but no longer than that.
Yeah.
But the conditions in Venus's atmosphere, where it has essentially standing water in the atmosphere in the form of moisture droplets, means that what is transitory on Earth can be permanent
Yeah.
on Venus.
So let's talk about that paper that Sarah Seeger and team published about what possible mechanism, how could life be surviving on Venus?
So the first thing to remember is don't go to the surface of Venus unless you're trying to melt a spacecraft, because that's how you melt a spacecraft.
Right. Yeah.
The surface is hundreds and hundreds of degrees. Whatever unit you pick, it's death. But if instead you go up in the cloud layer between roughly 50 kilometers up and 60 kilometers up, you're looking at an atmosphere that has Earth-like temperatures
And
and
Earth-like pressures.
one atmosphere pressure. Now, as soon as you get down as low as like 30 kilometers, 33, 35 kilometers, it's death again. But you have that window. And so the idea is that Venus, like every atmosphere, has currents within the atmosphere, and it has what are called Hadley cells, which are circulation regions in the atmosphere, where in the equatorial areas you have hot air rising, and then it comes down cooler towards the poles. And so the idea is that there's this haze layer down in the 30s kilometers up. And air from this desiccated, dried out death haze layer is able to rise up. Now, what if there were spores, desiccated life forms in that haze layer? They can then act as seeds to moisture droplets. We have the same thing happens here on Earth. It is around dust particles in the atmosphere that rain droplets form, or this is how we know you can seed clouds and it works. So you have these spores that act as the seeds of moisture droplets that are rising up through the atmosphere, and as they rise up, they can get bigger and bigger, taking this desiccated life form, re-moisturizing it, allowing it to thrive, to multiply. And as the water droplet, or moisture droplet rather, gets bigger and bigger and bigger, it'll eventually get too big as it's circling through the atmosphere. And as it falls back down, that water droplet, moisture droplet, will fragment, and eventually the life will be driven to desiccate out again. And we see life forms desiccate out here on Earth. This is something tardigrades do. It's why you can shoot them up into space and they come back to life.
Yep.
We could have tardigrade-like life cycles.
Yeah.
But a different extremophile.
Now you keep saying water, and then you keep editing yourself to say liquid. Let's talk about that liquid, because there's some water. I think there's like 15% water, but there's 85% not water, sulfuric acid.
Right. And so yes, the Venus atmosphere is largely death by acid. Mm-hmm. Largely death by acid. But largely is not the same thing as completely death by acid. Here on Earth, we have extremophiles that are quite happy to deal in just about any environment you put them, whether it be radiation, acidity, heat. We can find the life to live through it, and a lot of it's at Yellowstone.
The one interesting thing is they've actually looked at the level of acidity in this sulfuric acid, and it's super bad. Like it's worse than, it is more acidic than any environment that life has been able to survive in. But the key is that you've got these droplets of water that are dissolved into the acid. And so the thought is that in fact you could have the life living in the water that's in the acid. As long as it stays in the water droplet parts inside the acid, then it's able to survive going through this cycle. And so the liquid builds and builds and builds as these droplets rise up in the atmosphere and then rain back down. And hopefully the microbe has completed its entire life cycle before it turns into rain and falls back down, before its spores end up back down at that 33-kilometer haze altitude, and the whole cycle continues. But theoretically, they did the math, and this could go for hundreds of millions, billions of years, just over and over and over again.
And this is where you can start to speculate wildly. I'm admitting this is science-based wild speculation.
My favorite kind.
that when whatever catastrophic event occurred that caused the runaway greenhouse event on Venus, whenever that occurred, if it was a world like our own that had a vast diversity of microbes capable of surviving in pretty much any niche in the environment you can imagine, there's the chance that some of them could have figured out how to rise up in the clouds, or been carried up and just happen to survive and find a way to evolve over the generations to be what was needed, life finds a way.
So suddenly everyone is asking what spacecraft are at Venus that can help confirm this discovery.
None,
None.
none.
Yeah. There's the Japanese Akatsuki spacecraft is there, and it can see, wind and
Yes.
atmosphere.
And that is all well and good, but not entirely useful.
Yeah. Bepi Colombo from the European Space Agency is on its way to Mercury and is going to be able to do a flyby of Venus and be able to do some detections. But we're going to need something custom built for this.
And ideally, what we want to do is take things on balloons or gliders and have a way to go down to these various altitudes within the atmosphere and ideally carry an instrumentation package that allows them to grab up samples of the atmosphere and then look at them
Yeah,
under a microscope they took with them.
right. Or sample, return them home.
See, that starts to become far too large of a mission at that point. We want answers faster than that.
Sure.
Sure, do that in a
Yeah.
generation or so, but
Yeah.
life is short. Build the Discovery class mission now.
Yeah. There's a couple of missions that have been in the works.
Yeah.
There's one from NASA. There's
Da
one.
Vinci.
Yeah. There's one from which was just dropped into the atmosphere. There's some suggestions of balloon-based missions which will hover in the atmosphere of Venus and even go up and down in altitude to follow some of these thermals. The Indian Space Agency has a mission in the works. The
And
Russians have
Rocket
one.
Lab.
Yeah. Yeah, we saw Rocket Lab actually has a Venus mission that they had been planning that they dusted off. Again, coincidence? Maybe?
So the Rocket Lab one is the one that amuses me the most. It'll probably be the fastest to complete. The entire spacecraft will be about 15 kilograms. They'll have 3 kilograms for instrumentation, not a lot of power. But let's see how creative we can get in figuring out how to do this. We built a little tiny itty bitty helicopter for Mars. All we need is a balloon for Venus.
Yeah, yeah. But there are some other plans as well, things like the Havoc mission, which would send blimps, even human operated blimps, to the cloud tops of Venus. And then they would use a blimp-based rocket to return back to Earth. Because it's still, like, you're still going to have about 90% the force of gravity once you're in the... It's easy to get to Venus, easy to enter the atmosphere as long as you stay off the ground. But it
I
is
feel
tricky to get home again.
I feel the need to point out that, like Mars, Venus doesn't really have that whole magnetic field thing going for it.
Mhm.
And so, if you don't like your astronauts, sure, send them there before we have figured out how to take care of radiation.
Well, it does have
But
that atmosphere, though. It helps.
it helps, but you're not going to be too deep in the atmosphere.
Yeah.
So.
Yeah, you're going to be up pretty high. So,
And there's the whole getting there part, although it's faster to get there. And the cool thing about Venus, unlike Mars, is because we're outside Venus's orbit, there's multiple
yeah.
landing approaches per year.
Yeah, we can go there pretty much anytime we want. Unlike Mars, we have to go every 2 years. So,
Right.
a lot more opportunity to go there and a lot more opportunity to come back with that sweet sample return mission that should be in the works right now. All right, so now you're all caught up, everybody, on the discovery on Venus. Obviously, we will keep you filled in every new discovery that gets made as this goes. It's one of the most exciting discoveries in the field of planetary science and astrobiology in years, and could act as the cornerstone of our future searches for life across the universe. So hopefully, this is really exciting.
It really is. And if you want to hear interviews with David Grinspoon, who's one of the researchers who's been studying the potential for life, or with Sarah Seeger, who's one of the authors of these research papers, check them out over on dailyspace.org. This is the short form daily podcast we put out from CosmoQuest.
Fantastic. All right. Well, thanks, Pamela. Do you have some names for us this week?
I do. As always, our show is brought to you by you. You are the reason we're able to keep doing what we do year after year after year. So right now, I would like to thank Jordan Young, Burry Gowan, Burko Roland, Ramji Anmatu, Jeffrey David Macarsini, Andrew Palestra, David Trog, Brian Cagle, the giant nothing, Dan Littman, Robert Plasma, Laura Kettleson, William Les Howard, Paul Jarman, Joss Cunningham, Corey Davilo, and Emily Patterson. Thank you all so much for being here and being part of the numerous people that support our show.
Thank you, everybody. And we'll see you all next week. And then they saved.
And then they saved. Oh, so much science, so much desire to wildly speculate. My favorite Twitter that I saw was that they had found the what's the term from Expanse? I just lost it.
Oh, the protomolecule.
Yeah, they'd found the protomolecule. That was my favorite. Not that I succeeded in remembering the details until today.
That's about right. Are you caught up on the Expanse yet?
I think so.
Okay.
They
got to that world across the gate. Okay, cool.
Yeah, and
good.
Yeah.
Okay, so then you're caught up.
Yes.
We don't want to spoil.
No spoilers. No spoilers. Now, my current thing is I'm watching Lost in Space, which is just a fun romp.
Yeah, I tapped out on that one.
I think it gets better.
Yeah. We watched Away, which is the new series on Netflix about astronauts making their way to Mars. And so here's the one thing. For the first couple of episodes, I wasn't able to find a single scientific mistake. And I tried. Like, I really tried to find any mistakes at all. And it was tight. The one downside was just how sort of unprofessional and uncohesive the team was. The astronauts themselves were. So they were like a bunch of angry school children interacting with each other, and that was disappointing. But the actual how they handled, being very clear about when they were in zero gravity, when they were in artificial gravity, when they were on the moon. They even showed them walking carefully on the moon in lunar gravity, which I've never seen anybody do before, which was really smart. And they also didn't do a great job with communications delays, because on a trip to Mars in the beginning, you have almost no communication delay. And by the end, you have about a 3-minute, actually it's longer.
Yeah.
And so after a while, and they just sort of shifted from no communication delay to asynchronous communication. So that was a problem. But apart from that, I thought it. But when you weren't looking for it to, it was just talking. It was more about the impact on families and interactions, and it was a drama. So it was fine. We watched it through to the end, unlike Lost in Space, which we tapped.
That sounds good.
Yeah.
Yeah.
All right, let's take some questions here. We've got a couple of people asking about whether the Soviet spacecraft could have infected Venus with filthy Earth life.
Yeah.
To the point to create that much bacteria?
No.
Right. Okay.
Those are two different questions. Could it have affected? Sure. Could it have produced what we're observing? No.
Right. And I think it's just a matter of scale. Like on the one hand, you've got the possibility that a certain strain of cyanobacteria clinging to the outside of a Venusian lander may have just maybe not died instantaneously and could be now attempting to compete with the native Venusian
I'm pretty sure. So I can imagine us accidentally getting something on Mars that is able to just vaguely cling to life near the landing sites.
Yeah.
I'm pretty sure anything we took to Venus might go a cycle or two and then tap out. Just, I'm dead now.
Yeah. But to account for 10 out of every billion molecules in
Nope.
the atmosphere of Venus, no.
Nope.
Give it another few 100 million years and maybe. Side MT asks, does the presence of phosphine indicate life existed recently, or could it be remaining from ancient times?
This would need to be an ongoing process because the phosphine does get broken down in the atmosphere.
So some source has to be replenishing it right now.
Yes.
Okay. Hal McKinney asks, when was each of your first podcasts?
February 14th, 2005.
That's when you did your first podcast?
Mm-hmm.
That was the
That was Slacker Astronomy.
Slacker Astronomy, yeah. I think I recorded some episodes of Universe Today. I'd made some episodes, some audio episodes before Astronomy Cast, but someone's posting in the chat that our first Astronomy Cast was September 10th, 2006.
Yeah.
So that's when we started doing this podcast together.
And we talked about Pluto because
Yes.
the IAU had just demoted it.
Yeah. Deadlift Crows asks, how much do discoveries like this one influence the decadal survey process? That's interesting.
So I asked about that yesterday, and Sarah didn't really have a sense. What I know is they're still taking decadal survey white papers, which means that I suspect that right now a whole bunch of people are madly adding to existing Venus papers. Because there was already a fairly mighty contingent of humans that wanted to go to Venus with a spacecraft, not with themselves, but with the spacecraft. So I'm hoping that this will increase the likelihood that a Venus mission will be prioritized.
That would be cool.
Yeah.
Quadlibit asks, it's often been speculated that possible life originated on Mars, and we got it because of asteroid strikes in panspermia. Would it be possible to get bits of the Venusian atmosphere to get to us?
Atmosphere you can't really carry with you, but if in the far past when it had a habitable surface, if that is something that existed, panspermia could easily have carried stuff to us.
Yeah. Uncle Willie's asking, could the Parker Solar Probe help on its Venus flybys? I don't think it's got the right machines.
It really does not.
Yeah, it's got the right equipment.
Soapbox Rocket is pointing out in the Twitch chat that they remember being on a round table for the Singularity podcast in 2005 or 2006. I think that was 2006 that occurred. It's crazy the way that our community has been around for so long.
We were on that together, or you were on that?
I think I was on that, and then Soapbox Rocket, whose name is not actually that, so I'm not sure who on the panel it might have been.
Yeah.
Soapbox Rocket was on the panel.
Right. Uncle Willie also asks, what group of biosignatures would, when taken together, rule out all non-biotic answers? That's a great...
We don't know that yet.
But it is the right answer, because it's probably going to be that it's not going to be any one chemical is going to be the biosignature. It's going to be this collection of chemicals in ratios.
And I mean, my honest take is that if you see the combination of pollutants from industry in combination with free oxygen and things like methane and propylene, that kind of combination is going to be the kind of thing that starts to get us excited. Now, if you see that in concert with an IR excess indicating heavy spaceborne equipment, you've found intelligent life. Mm-hmm. But we haven't found that, nor do we necessarily have the technology right now to find it.
Ben Kalo asks, what could be feeding the microbes in the Venus atmosphere? What's the energy source and phosphine producing microbes on Earth?
So on Earth, it's a part of the decay process. They eat dead things.
Hmm.
And in fact, one of the things that I saw and have not confirmed, is that if this gas existed in large amounts, it would smell like death, and
Yeah.
it would also be toxic.
Yeah, it would
So
kill you.
don't try.
Yeah, don't
Yeah,
breathe this stuff. Yeah, don't try to produce phosphine at home.
no, this is how you die.
This is how you die. Yeah.
Um, Now that said, the requirements for life are nutrients, which don't have to be all that complicated, a temperature gradient, which they certainly have, and a solvent, and they have that.
Right.
So you don't have to have plants. You don't have to, you can exist by having nutrients that you can scoop out of your environment, carbon, nitrogen.
Yeah.
Plants basically eat the atmosphere. We don't think of it that way,
Right. Right.
but that tree growing in your yard, rising up the sidewalk, it's taking carbon out of the atmosphere to build itself and releasing oxygen while it keeps that carbon.
One of the interesting ideas in that paper was they were talking about how all of those chemicals are available in the atmosphere:
Yeah,
carbon, nitrogen. Like people don't realize this, but actually Venus has twice the amount of nitrogen in its atmosphere that Earth does.
I had no idea.
Yeah, in just total mass of nitrogen in its atmosphere. Even though its
It's
atmosphere is
tied up in
almost
molecules.
entirely no, it's just even though its atmosphere is almost entirely carbon dioxide, it has so much mass in its atmosphere that it has double the nitrogen that we have in the Earth one.
Okay.
It also has even more carbon dioxide, to the point that it's like 90 times the density of Earth's atmosphere. So it
So
has all these
this is by
chemicals.
mass, not by percentage.
That's right. Yeah, by
Okay,
mass.
that's the key.
If you
Yeah.
take all the nitrogen out of the Earth's atmosphere and you weigh it, and you take all of the nitrogen out of Venus's atmosphere, you'll have twice as much on Venus as you have on Earth. And then if you take all the carbon out of the atmosphere on Venus, obviously you're going to have much more than you have on Earth. And in fact, all of those chemicals are available in the Venusian atmosphere. Obviously, we've got hydrogen, we've got sulfur, we've got oxygen, carbon. The ones that might be tough would be some of these heavier metals. And
Yes.
they propose that, in fact, that's the rate limiting step, is the amount of these heavier metals that are needed for various biological processes. And they propose that there's a constant rain of meteorite dust that is coming from space like we have here on Earth. We have tons every day that's getting added to the planet from meteorites raining down on the Earth. And that could be seeding the atmosphere with these heavier, more rare metallic elements that are getting trapped in droplets, getting carried around into the atmosphere as well. So it's quite interesting. They sort of thought about these things.
And there's always dust thrown up into the atmosphere. It can be coming from both directions. It's really amazing to think about,
Yeah, it is.
especially if there are active volcanoes.
Right, exactly. And so this is, I mean, I think that, we sort of glazed over that, but this possibility that Venus still has some active volcanoes on it is really exciting and really contributes to this, as opposed to being completely volcanically dead.
Right.
Nicholas B asks, how likely is it that the phosphine is a false positive?
I think that they probably got the observation right. They did all the things right in terms of looking up what are all the possible sources of absorption lines
Hmm.
at this particular wavelength. There was one particular molecule that was discovered that could interfere with that wavelength. However, when they went to a different wavelength where that line also would have occurred, because spectral lines come in groups. You don't just get one spectral line from an atom, you can get a family of them. So when they looked for one of the other lines of that molecule, it wasn't there. So it seemed to indicate that it was a real phosphine observation.
Yeah, yeah, and I mean they did it's beautiful to see you can see the initial signal line with this clear absorption of phosphine at this 1 millimeter line. But it's very blocky with the original James Clerk Maxwell telescope that they
Yeah.
used. And then they did a follow-on observation with ALMA the Atacama Large Millimeter Array, and it is one of the most powerful telescopes on Earth. And it is that same signal, but with more resolution, so you can
Yeah.
see the beautiful exact point where the phosphine is absorbing in the 1 millimeter bandwidth. So it's a beautiful piece of science, and literally they took 3 years to make sure that they weren't saying that they saw something that wasn't there, because that would be embarrassing.
And this is where we have to be excited about future telescopes, for instance, the Square Kilometer Array, that will be able to look in different wavelengths to look for different bands of this particular molecule. So I'm super excited to see what is possible. And some of the other things that we're going to have the ability to do is Venus is order of 10 arc seconds across, and that means we can get multiple resolving elements across it. So we can start to look for latitude and longitude differences. And with longitude, what I mean is if you look at the crescent sunrise versus the crescent sunset, you may be able to see how does this vary with temperature and sunlight and so many other different factors.
Yeah, it does feel like a reset, though, just in priorities and where telescopes are pointing. And I mean, there are a lot of really sensitive instruments they take really high quality shots of Jupiter every year with Hubble, and Saturn every time we reach opposition with those two planets. But I don't think I have seen a lot of stuff coming back from Venus. Maybe it's too close to the sun
Well,
to
so
point
so
Hubble
the
at, right?
problem that we run into is those beautiful images of Saturn and Jupiter that we take are taken when Saturn and Jupiter are at opposition, where the
Once a
sun is
year.
behind us and we're looking out towards them, and they're at their closest point to the planet Earth. So what we have is sun, Earth, and then my microphone, which I don't know if it's on the screen for everyone or not. So let's call my microphone the sun. So then we have the Earth here and what we're looking at. So either Saturn or Venus, and they're at their closest point to the Earth when they're full. Now, the problem is that when we're looking at Venus, we have Earth here, and Venus is on the far side of the sun. So it's at its smallest size when it's full.
Yeah.
And it's close to the edge of the sun, where we really don't want to point our telescopes. So because Venus has to be at conjunction, lined up with the sun in between us and apt to appear full, we're stuck.
Right.
It's a new Venus.
Whenever it looks best, whenever it's biggest and best, it's new.
But the crescents, I love the idea of being able to look at sunrise and sunset.
So, right. So I think that, I mean, obviously the answer is an incredible new mission. And I guess that's the problem, right? Is that nobody ever thought that we need a flagship at Venus. Venus sucks. I've been campaigning to just push Venus into the sun now for years.
And you might have caused genocide. Little did you know.
Little did I realize that I could have been the cause of a lot of tiny bacteria dying. So I hold off that. I've given it a stay of execution. We're not going to push Venus into the sun today. Instead, we should send a flagship.
And this is where my heart breaks, because I know a flagship mission is 10 to 20 years to complete.
But Venus is so close. You can get there in just a year. You can get there in a couple of months.
I understand, but to just build the sucker.
I know.
And like, I'm in my mid-40s. The clock is ticking.
Yeah.
I want answers. So finish the Square Kilometer Array faster. That's slightly more practical, maybe.
Yeah. I wonder if you pointed the Square Kilometer Array at the atmosphere of Venus, would it be sensitive in that 1 millimeter wavelength?
Well, but the molecule has other lines as well, and that's what I want to see, is those other lines.
Right. So probably higher and lower on the spectrum. Yeah, that's really interesting. Yeah. So hard reset. Everything's up in the air. I think it will be a weird time for the decadal survey, which is just trying to wrap up now, having to go, whoa, what about Venus?
Well, at least the one good thing to come out of COVID, other than working at home, is white paper deadlines were delayed. And so they are still accepting white
Yeah.
papers, or at least they were last week.
So somebody
So,
hurry with their
yeah,
Venus flagship Life Finder.
yes,
Perfect.
exactly.
Awesome. All right. Thank you, everybody, for joining us this week. Thank you, Pamela. We're going to try to do the virtual star party on Saturday night, but
Good.
still the fires rage across many of the areas that we have our telescopes. So if we still have bad seeing conditions, we might have to push it back another week, but we will try to start the
Yeah.
show up on Saturday nights. We're not doing on Sunday nights. We're doing on Saturday night. But it's still like we're in
Thank you.
planet season now. So we've got Saturn, Jupiter, Mars, the moon, Neptune, Uranus, like everything's up. And so we'll be shifting from deep sky objects to planets. So it should be a lot of a lot of fun. Thank you to our moderators. Thank you everyone watching us. Thank you, Pamela. Thank you everybody on
Frasier.
Twitch. We see you. And we will see all of you next week. Thanks, everybody.
Goodbye.